talk to you about multi-charged. Some elements have more than one charge. You can see this on your periodic table. Hi, it's me again. This is your table. And on your table, you've got elements like iron right there, which have more than one charge. Got it? That means there is choice. And if there is choice, that means we're dealing with multi-charged, and that means we have to add one more step to it. So we're going to pick on iron today. I have iron 2+, iron 3+, and I'm going to have iron 4+. And I'm going to combine each of these with oxygen. Oxygen 2-, oxygen 2-, oxygen 2-. Now, the nice thing about multi-charge is it's never a negative thing. It's only ever positive. So we really only have to worry about that when it comes to these positive ions that we're dealing with, these cation ions. Now, the very first one that we have here just cancels. 2 and 2, cool, cancel, cancel, and I get FeO. Now the next one doesn't cancel, so it does not cancel, does not simplify, so I go right to crisscross, and I have Fe2O3. Now the third one does simplify. We've got a 4 and we've got a 2. So this is going to be treated as a 2. This is going to be treated as a 1. And then I'm going to crisscross. That going here, this going there, and not mattering because it's a 1. And we're going to have FeO2. So all three of these are compounds of iron and oxygen. Now, when I go to name them, you will notice that there's a bit of a trick, a bit of a problem, because this is iron oxide. This is iron oxide. And this is iron oxide. Well, fudge. That can't be right. These are obviously different things. I mean, there is a complete different ratio between iron and oxygen. And, you know, it starts out with the most iron and ends up with the least iron as we go. So there's got to be something with this. And that is where these multi-charged things come into play. See, we need to show which charge of iron that we had when we write our name. And we're going to do that by putting Roman numerals after the iron, before the oxide, representing what we started with. So this was iron 2 oxide, because the iron's charge was a 2. This one over here, we get from the 3, and it becomes iron 1, 2, 3 oxide. And this one, we go with the 4 that we started with. And this is iron IV, or 4 oxide. So again, those Roman numerals are only used if there is more than one possible charge, and the numeral itself is the charge of the compound. Now, if you go on the Google Slides, you can see this going forwards and backwards, talking about how multi-charged can be also deconstructed. If you have the name, such as this iron 2 oxide, iron 3 oxide, iron 4 oxide, then your life is a lot easier and you don't have much to worry about. If you don't have the name, you have to work backwards. You have to separate the cation and anion. The charge of the anion, you can always look up off the table, and you can use that to figure out the charge of the cation. So that is multi-charged.